Hyperparameters are the tunable settings that controls how a machine learns or how a model learns. Welcome back to my channel. Hope you all are doing good. Today we are going to start with hyperparameters and its concepts, and we will start with the topic now. Let us understand on how our hyperparameter works and hyperparameter and hyperparameter tuning works. Both things we'll understand in this. So what is a hyperparameter? Before going here for tuning part, let us understand on what is a hyperparameter. So hyperparameter is a variable or the factors or the the characteristics which are considering, and those are external configurations which we are setting before training process begins, and based on that your model will learn the things. So just like your model parameters, like when we're talking of model parameters where we are telling weights or loss or bias. So weight and loss, weight and bias is a part of neural network. We will understand that in our deep learning. So those are our model parameters, and those model parameters, what it is happening, which are getting learned during your training process, right? However, hyperparameters are not the same. They are not getting estimated, they are not getting considered during learning or during your training phase. Those should be considered before the training process begins. So with this process or with this hyperparameter, we can understand the complexity, the learning rate, and the regularization strength of the model. And here, if you see this image, let me just zoom it out a bit. So if you see this image, what exactly it is, like at which step we are considering our hyperparameter. See, so what is the first step, guys? We are getting our data, right? Then we are splitting our data into training data and test data. And test data, there is a small part of validation data we are considering. Then the training data is going for the model training, correct? Right? And the validation data, we are predicting the output, right? We are predicting the output. Predict. So when the training data comes into picture, model training comes into picture. And the hyperparameter tuning part will come before training the model. So before training the model, what we are observing, we will get the correct parameters which will give me the better accuracy, the highest prediction of the model. So this will give me that output, and that output will pass to this model training. Then we are getting our predicted output. Then we are getting the evaluation results or the accuracies out after that, right? So that's how my hyperparameter takes a role in a model study or in a model evaluation. Then when we're talking about hyperparameter, then there are different types of hyperparameters, right? When we're talking about different model hyperparameters, and another is the algorithm hyperparameter. So model 1 is going to be like, when we're talking on model, if we take a decision tree, we are considering different number of layers, then depth of a tree, right? Based on that, your model's architecture and complexity are going to be defined. However, in case of algorithm hyperparameter, which controls the training process, right? Which controls the training process, and here we are considering, okay, the learning rate, that's a hyperparameter, right? Then batch size, when we're talking about L1 and L2, lasso and ridge, during that time we are considering alpha, right? The alpha ratio, the alpha part, the alpha we are considering 0 to 1 and 0.5 we are considering. So those are your hyperparameters. We will evaluate on what regularization technique, at what point we are going to get a correct output, and based on that we will proceed on the model training. So those are different examples, and again in case of model parameters, here this few examples I have shown already. I have told you few, but here these are the exaggerated explanations. So one is a number of layers or the nodes in neural network. So neural network is again like a brain, human brain like structure which a model is getting formed when getting trained, while getting trained, right? So in case of number of layers, we are understanding the model's depth and width of the understanding. Then kernel type is a factor in case of SVM, support vector machine. Kernel type we are considering that. Then which specify, or this function specifies the data, or how to map data on higher dimensions, right? Then we have tree depth. In case of decision tree, we are understanding uh, because the more depth it is going to be, the more complexity it is going to control. So the tree depth should be higher in case of decision tree. Then k nearest neighbors. If we'll take k nearest neighbor as a classification algorithm, so we are considering k. So k is a factor which is going to define my neighbors, right? So these are different kind of hyperparameters, and I have shown you few hyperparameters, and these are model hyperparameter. And when we're talking about the algorithmic hyperparameter, those are going to be a learning rate, then your batch size, right? Batch size when you're considering deep learning, epochs, deep learning, then momentum, then regularization parameters. Okay, that is again one of the algorithm parameters. Then how our parameters and hyperparameters are different among each other? So again, hyperparameters are getting set by the practitioners during your training or before your training. Then it controls the whole learning process. Then in case of parameters, those data are getting learned during your, or those are getting trained during your training process. Where it's bias, right? Then we have regularization technique, those things. Then we will understand what is hyperparameter tuning. We understood the concept. Now we will see how it is helping on tuning the model. So what is the process? What is the tuning process, guys? So it involves, so here if we'll see the range of hyperparameters, those are going to be high. So it will identify each range of each hyperparameters which are getting used in the model. It will understand that, and it will give you the, or it will help by cross validating those combinations, and it will give you the best performance. So we have different techniques, different methods. Again, we have GridSearchCV, RandomizedSearchCV. Those methods are helpful along with the cross validation. It's going to give you the output, or those are the different tuning methods. So in short, you can keep it in mind that okay, the hyperparameter tuning process is something where we are getting the best out of it. The best hyperparameter which is getting considered, we are like getting, or we are identifying from this process. Then finally, once the model is getting trained with the optimal hyperparameter, then we will evaluate the test set rate to estimate the performance of new and unseen data, right? And there are few steps to perform. How we are performing in theoretically, we will understand that. Then when we'll go ahead for practical perspective, we will see that as well. So what is the step 1? We will identify and define our hyperparameter. Suppose if we are considering elastic net, we have to use L1 and L2 ratio, right? Then step 2, we have to choose the tuning method. Either you have to use GridSearchCV, Bayesian optimization, or RandomizedSearchCV. Then we will evaluate the model performance with that method. Then we will select the best hyperparameters, and again we will retrain the model. So this is the step on how we are performing the hyperparameter tuning. Then again we have different methods to perform that. So what are the methods? One is a manual method. In manual method, we are going with our understanding, or we are with our intuition. Okay, which hyperparameter can be used, which can be best. So again, trial and error basis we are getting here. So it's not a systematic approach. If we'll understand the method, manual method, then it is very easy to miss few optimal variables here, right? Or few optimal values also we can miss here, because again human intervention is there here, right? And it is not going to scale better, or it's not a good case for multiple hyperparameters. Then we have rule-based training. So one we understood manual, then we have rule-based. So in case of rule-based, we are going ahead with industry rules and best practices. We can we'll with a broader range, we will reduce that to narrow range. Suppose few examples if we consider, the learning rate usually comes between 0.001 to 0.1, which is a sweet spot. Then a depth of the decision tree should be usually 3 to 15. So we are reducing the range. Then batch size common values we can take 32, 64 and 128 when we are considering neural network training, right? So those considerations we are using with rule based, and it is very helpful to set sensible range before applying the advanced search. Then we have search based method. So we understood rule based, we understood manual method. Now we have search based method. So in search based method, which we are using most frequently and most useful methods, these things are. So one is a grid search CV, grid search. So grid search, what we are doing, it tests all combinations of hyperparameters, right? And it works. How it works? It will define a range. Okay, so here it will define a range such as like learning rate with 0.001 to 0.01. Then algorithm tries all combinations which is coming in between, and it will give you the best one or the best learning rate to train your model. So what are the pros present here in case of grid search case? It's exhaustive because here the process takes huge, it takes more processing power. That's why it is exhaustive, and it makes your system or the process simple at the same time. And it guarantees coverage. It will cover everything in case of grid search. And what are the limitations? It's slow as compared to other methods. It's not scalable. We cannot use for the larger data, high dimension data, we are saying. Then it is inefficient when we are considering many parameters in case, and it works poorly in case of high dimensions data, like I mentioned already. So these are the limitations. So to avoid these things, we will be having something better, which is random search. And again, random search is based on what, guys? It is based on your trees, number of decision or number of iterations. So here again, randomly it selects combinations within the given range. So if what is the first thing, guys? We are defining a range. So in case of random search, instead of going each time each value, it will randomly select few from that range and it is going to perform. And with this approach, like there are so many advantages and the limitations at the same time. So we have pros. This is faster than efficient as compared to grid search, and it is better. It will show better for larger parameter specs. Then limitations, again here we have few limitations. No guidance. Okay, from previous trials, there won't be any guidance for performing this. Everything is randomly happening. Then we have latent hypercube sampling. This is again one more search based method. However, the important ones are your grid search CV and random search CV. And if you see the like how it works, again it will take it is a smarter form of random search CV or random sampling, which ensures even coverage of all specs. So in case of random, what exactly you are doing? You are defining a range. Suppose I am defining a range of so I'm defining a range. So let me take my pen. I'm defining a range for learning rate. Okay. So I'm defining a range of 0.001 to 1. Okay. This is my learning rate range I am taking. So what it will do in case of random sampling? In case of grid search CV, it will go for each value and it will give me the best. However, in case of random sampling, the method is reduced, and from this range, it will take random one, like random it will search and it will give. However, in case of latent hypercube, it will take all those combinations which will cover everything. It won't leave anything from it. Then it works as like how it works, it divides the space, then sample again from the interval and combines all the samples, and it is covering everything. So for that, due to that, there are a few pros and cons even in this case. So pros are like it ensures that each hyperparameter range is covered uniformly, and it is good for continuous variables. It is better for continuous variables. Then few limitations, it is very complex because more iterations will be there, so that's why it is complex, and it is not adaptive, so nowhere it is getting used most of the times. Then we have Bayesian optimization methods. So Bayesian method, again, what exactly it is, guys, we already understood. Bayesian method is a probabilistic method, right, where we are considering the probabilistic approach of all variables, and we are proceeding on getting your prior, then posterior, and all these things, right? So again here there are a few steps. What are the steps? First, it will build a surrogate model. Then it will predict which parameter will perform best from that, and it uses accusation functions to balance explorations. So what are my accusation functions? These are expected improvement, upper confidence bound, and probability of improvement. These are theoretical part, guys. You need to remember this. Then there are few pros. Okay, it requires lesser trials. Then it understands the past evaluations. Then it's ideal for expensive models. So whenever you have any expensive study to be made, Bayesian optimization method can be considered there. And we will see everything during our practical example, like what are the properties or how we can trade on your different methodologies like Bayesian optimization methodologies. Then we have tree structured Parson estimation, PP. So tree structured Parson estimator is again a Bayesian optimization. It's a scalable form of that, and it models good hyperparameters separately from bad ones. So because it is going to create tree structures, right? It is going to understand which one I should consider, which one I should not. So it will treat in that way. And there are different methods by which we can get. So one is a hyperop, then optuna. These are the different paths or different methods where we can use this, and it handles high dimensional spaces. It is very good for high dimensional data and works well with continuous and categorical both. Then we have different models where we can use this hyperparameter tuning methods. So we can use it in deep learning and XGBoost. So early stopping is the one where we can use. So it helps, right? It helps in handling early stopping. Then prevents overfitting. Then it saves time because you don't have to understand each hyperparameter manually. It is giving me the range, or it is going to give me the best hyperparameter which I can use for my model study. Then works extremely well with all kind of different models because we can use this in XGBoost. This is the ensemble technique, light BGM, neural networks, and hyperband in case of deep learning. So like that, I mean, it can run with many models. Then faster than grid search, best for deep learning, hyperparameter tuning, and used in Keras tuners. So these are the different tuning methods, guys. These are the different tuning methods. So I can say that Bayesian optimization is the most sophisticated hyperparameter tuning method, and mostly it is used in case of your different kind of deep learning techs. In that stack it is getting used. So even hyperband is one more method which we can use in extremely well in deep learning. So these are the different things, different methods, and in short, In short, hyperparameter can be used in both regression and classification, and I will show how it is getting used in case of regression, and during classification also I can show on how it is getting used with ensemble techniques and all, because we saw XGBoost it is used, and it performs well with them. The Bayesian optimization and even the other optimization techniques, we will see that. So we'll meet during our next video. Thank you. That is all for now. We will talk about, or we will understand on how grid search CV, random search CV and all those things are going to work on our next video. And till that time, see you. Please start subscribing if you really like the content. If my content is very helpful to you, please go ahead and do that. Like, share your comments, share your feedback, share this channel link to all your friends and near ones. Don't forget to hit the bell icon while subscribing. That is most important, because the contents are going on regular basis. Do not miss them. And see you. Bye.